We've all seen beautiful sunsets and sunrises before in our lives, but what is it that makes them so colorful? What makes the red and oranges and sometimes the purples and pinks, and why are they only seen during sunrises and sunsets? In fact, why is the sky blue? The colors that we see in the sky are due to the electromagnetic spectrum and the way the visible light waves interact with the physical properties of the atmosphere. Out of all the wavelengths that exist, humans can only see waves from 400 to 700 nanometers. When we see something as a certain color, it means that that object is absorbing all colors but that one that is reflected back to us. White is what we see when all the colors are reflected back, and black is what we see when all the colors are absorbed.
When light from the sun hits molecules in the air and bounces off in another direction, the type of scattering that occurs is called Rayleigh scattering. The amount of Rayleigh scattering depends on the medium. The closer the particles are to the wavelengths in terms of size, the more scattered the light is. Because the Earth's atmosphere is primarily made of oxygen and nitrogen, those small molecules, blue and violet light, the shortest wavelengths, are scattered more effectively, and as humans are more sensitive to blue light than violet light, the sky is seen as blue.
During sunsets and sunrises, the sun is at a much larger angle to the normal than at any other time of the day, which means that the light from the sun has to pass through more gas molecules and dust. By the time the light reaches your eyes on Earth, most of the blue and violet light has been scattered away. What is left are the longer wavelengths that are not as easily scattered by the small particles, red, orange, and yellow.
The angle is also what makes us see the sun as yellow and reddening towards sunset. Because of the scattering, the longer end of the visible spectrum, red, orange, and yellow, have a straight pathway to our eyes, and the sun gives off a lot of yellow frequencies, so we mainly see yellow. As the sun sets, eventually even yellow and some orange wavelengths are slightly scattered if the atmosphere is dusty enough, which can give the sun a reddish color.
There are many different factors that affect a sunrise and sunset. The amount of stuff in the atmosphere that will scatter light is important, for example, the presence of sulfur aerosols. Often the products of industrial pollution and volcanic activity absorb a lot of light and scatter most wavelengths. That means that the colors are more muted and dull when the air is heavily polluted. This is also true of the changing seasons. Sunrises and sunsets are generally brighter in the fall and winter because the air is cleaner, free from the pollen and dry dust of spring and summer. Clouds, made of large water droplets that reflect light, often make a sunset or sunrise more dramatic and colorful. A past storm as well can clean the air and project colors from the horizontal tail end of the storm to make the colors more pronounced.
There can be differences between sunrises and sunsets. Generally, sunrises are clearer and brighter, as wind often dies down during the night and allows the atmosphere to clear a little bit. By the end of the day, there's often more smog and dust in the air, so sunsets often have more muted, subtle colors and look messier, but due to the increased scattering, it takes up more of the sky.